Hi everyone! In this video, we're going to cover a topic called parallel arrays. Nothing new in this video, but we're going to take arrays to another level and apply them to solve problems that are very common. For example, in a few videos ago, we had code that was reading in from a file information for a student. Each student had three pieces of information about them. We had their name, we had their class standing, and we had their GPA. Well, if we wanted to store information for all students, their names, their class standings, and their GPAs in arrays, how would we do that? Well, this video is going to show you how we'll use arrays in order to store all three pieces of information about multiple students. So our solution is going to make use of something called parallel arrays. So let's open up a new file in the VM called parallel array fun so that we can code up an example of solving this student problem using parallel arrays. All right, some background on parallel arrays. Often we'd like to associate the values in one array with those in another array. For example, say we have an array of student ID numbers together with an array of student GPAs. Since those are two different pieces of information, in fact, they're different data types, right? Perhaps an integer or a string to store the student ID number, and perhaps a double to store the GPA. Those are mixed types. We can't put those in the same array. But what we can do is declare one array to store the student ID numbers and a separate array to store the GPAs. If the arrays are exactly the same size, then we could put the ID numbers and the GPAs at the same index position in each array so that they have a relationship. So for example, let's say we have 100 students. Here's an array of 100 ID numbers, which are integers, and here's an array of 100 GPAs. So here's what the arrays might look like, just with some example data. So the key here is the arrays are the same size, and the index position in one array contains a value that is associated to a value at that same index position in the other array. For example, the student with ID 1230 has a GPA of 4.0 because they are both at index position 0. Let's say that a student with an ID of 3523, that student has a GPA of 4.0 because they're both at index position 4. So this is just a small example of parallel arrays. The key to parallel arrays, two things. The first part of the definition of parallel arrays that I want you to know is you have to have two or more arrays of equal size. They have to be the same size because the indices must align. The second piece of information related to the definition of parallel arrays is this idea of the indices aligning. Data in one array at index position I corresponds to data in the other arrays at index position I as well. So there's kind of this one-to-one mapping. So we saw a small example of student ID numbers mapping to GPAs. Let's take a look at another student example following up with the advanced file IO fun example we had where we were reading information about students from a file. We had names of students, we had class standings of students, and we had student GPAs. So let's say we have 3 parallel arrays in order to store information about the names, class standings, and GPAs. If we head back to the VM, we can even open up that file from when we were working with the student information. So here's our students.txt file. So we have Jane student, Joe Schmo, and Mary Lamb. They are freshmen, seniors, and sophomores. And their GPAs are 3.5, 3.7, and 2.5. So I've just written that information up on the board here. These arrays are parallel because all of the information for the first student is at position 0 in all 3 arrays. All the information for student 1 for the second student, Joe Schmo, is at index position 1 in all 3 arrays. All of the information for the last student, Mary Lamb, is at index position 2 in all 3 arrays. So essentially we get this kind of relationship that looks like this. This is why the arrays have to be of equal size, because there's a one-to-one correspondence between the data in each one of them. So what we're going to do now is we're going to code up parallel arrays in order to store this information, and then we're going to write a simple function that's going to print out all of the student information from these parallel arrays. So let's go ahead and open up in gedit our advanced file IO fun.cpp file. Let's go ahead and copy all of this code and paste it in our parallel array fun.cpp file. We could hand type and resolve this problem. It would be great practice, but for the sake of time, I'm just going to go ahead and copy it over. Now the students.txt file is no longer in the same directory as my parallel array fun.cpp. It's in the /cpsc121/advanced file IO fun folder. So I just need to refer to that folder in order to open up this students.txt file. This is still a relative path because it's being specified relative to the current working directory of parallel array fun.cpp, which for me is CPSC 121. All right, so I can run this code and get the same output we were getting with advanced file IO fun. But now it's time to use arrays to help solve this problem. So let's go ahead and declare 3 arrays. we'll have student names, which is a string. We have to decide how large we want our arrays to be. Now, we know that there are only information for 3 students in the file, but we should make our array large enough that it could handle more than 3 students. So let's go ahead and declare a constant integer called num_students. And I'll just set it to be 100, which is larger than we need, but leaves room to grow our file. Right, our file has information for 3 students, but if we declare our array large enough to store 100 students, then for testing purposes, we could add more to that file and we wouldn't have to change our code. All right, now we want to populate our parallel arrays as we read in new information about students in our file. Right now, we're simply printing out the name. Let's no longer print out the name, but let's instead add the name to the student names array. I've got to add the name at an integer location in student names. And recall, this has to be consistent for all of my parallel arrays, such that Jane's student's name ends up at position I, Jane's student's class standing ends up at position I, and Jane's student's GPA ends up at position I. So that's pretty straightforward to do. Let's just declare an integer variable I and initialize it to 0. We'll use I to add the name, class standing, and GPA for each student. And then at the end of our while loop, when we're done processing a student's information, we'll increment I to prepare for the next iteration where we're going to process a new student's information. And now at the end of our while loop, we need to increment I. Now we'll go ahead and save, compile, and test. We don't have any output over here because we've taken out all the cout statements. So it's now time to write a function that prints the student information stored in the parallel arrays. So if you're feeling comfortable, go ahead and pause the video and try to solve this problem. If not, stay tuned. I know that parallel arrays are quite new, but the idea of printing an array is something we've already covered. We're just going to be printing information from 3 different arrays each iteration of our loop. All right, so I'm going to call my function something like print student info, and I'm going to pass in all 3 arrays as well as the number of students filled in the arrays, because even though we've declared our array size to be num students, we're only partially filling that array to hold I students based on the number of students in our file. Now we need a prototype and a definition for this function. So our first parameter is a string array. Our second parameter is a string array. Our third parameter is a double array. And our fourth parameter is an integer, which is the number of students in the arrays. Now it's time for our definition. Your output doesn't have to match mine. You could just list out the name, standing, and GPA, just like we did when we were reading it in. That's totally fine. I'm going to put mine in sentence structure though, so it's a little bit more clear, and it pulls together all pieces of the 3 different parallel arrays into one kind of unified representation. And there's our info. So this is really cool. We're able to read information in from a file, store it in an array for use at a later time. Like we're printing out the student info now, but we might next write a function that displays the average GPA of all the students, or maybe count the number of freshmen, the number of seniors, the number of sophomores. And we can do that with our array, our parallel arrays. So I think I'll put that down here just for a task if you want some extra practice with parallel arrays. You'll want to probably add more students to the file so that, for example, there are multiple freshmen or multiple seniors, at least a junior, multiple sophomores, etc. Another fun thing you could do could be, let's say, find the most commonly used first letter of the first name. Something like that. I'm sure you can come up with some other creative things, creative questions that you could ask and then answer using the parallel array.